Hey guys, welcome back to my workshop. As you can see, I have a nice new addition. A whiteboard to explain the secrets of the universe. We also are ready to tackle our next Code With Me challenge. Today I'm going to tackle the simple challenge. It's called Remove Characters from String. This one is going to be really easy because there's already some C++ algorithms to do most of the work for us. And that's why I picked this challenge, so that we can talk about some algorithms and so that we can learn a little bit about lambdas, because we're going to use a lambda. Are you excited? Alright. Okay, first we're going to do our boilerplate. Let's just create a new CPP. Okay, so we know we're going to be reading in from a file, so we'll get our good old F stream. We'll be printing out to standard out. So we'll get our IO stream. And we know that we're going to use algorithm. And we also know that we're going to be using standard string. Okay, let's just do some quick boilerplate in main and rc const char rv. Input and our output. Now we have our main function. Let's go ahead and check to see how many arg counts we have. If argc is not equal to 2, because we're going to get an input file, let's just return 1. Now, I didn't explain this last time, but standard Linux convention is that a function returns 0 on success and anything else on failure. So we just return 1. That's pretty standard. Then we're going to create our input stream. So if stream input from our argv of 1. Alright, so now we have our input file. And, well, get line of input. Oh, we forgot our string. Standard string line. So we're going to read our file into. Alright, so now we have our line of text. In this particular challenge, if we go to it, let's close that window. Okay. You can see, here's our input file. They are delimited by a comma and then followed by a space. So that should be easy enough to read in. So we are going to then do, alright, so we need two strings again. We need a string, our input text, and a standard string of our bad chars. Alright, so let's do another get line. Oh no. You know what? Let's be a little sneaky. We're gonna change this up. This is gonna be our input line. Input text. Alright, text. Okay, let's be a little bit sneaky. We're going to do input text. Oh wait, no, it's still input. But first we're going to read from our input text to a comma. That's going to be our line delimiter. So it's going to read up to that comma. And we're going to say and get line input bad chars. Okay. So now we have a while loop that's going to loop through our input file, and it's going to grab our input text and our bad characters that we're going to remove from our string. Okay. Now for the fun part. We are going to use std remove if. Okay, so this takes input text. It takes two iterators. Begin. So we're going to remove from the beginning of our input text to our input text.end. Alright, so now we're going to give it a predicate. A predicate in this case is just a function. This function takes in one of our items that we provide to remove if through the iterators, and if it returns true, then it means that we want to delete the object. If it returns false, then it means we don't want to delete that object. So I could do a function up here, test string that takes some standard string. Wait, no, this is just going to be a char because we're iterating over a string. So what we're going to get is a char c. And we could do something where, test for if c is in string, is in bad char. This is just pseudocode, blah, 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 return false, return true, return false. Alright, so we could do something like that, and then you could put that here, test string. But we would have to then make the input text and the bad characters, well no, just the bad characters. We have to make that a global. I don't really want to do that. So lambdas are our secret weapon. They're great, and they are just a function declaration. The syntax looks bizarre. If you've been coding a lot in C and C++, the syntax for a lambda looks crazy. But if you think of it as just a function declaration, and then we're going to do something goofy here. And I'm going to add something at the beginning of our function declaration. Alright, so we know we're going to get a char c. There, now we have this function. That looks really goofy. These angle brackets look completely, or these square brackets look completely out of place. But what they're doing is quite amazing. Okay, so this just creates a function object that we can call. So if we have auto lambda is equal to, say we have this lambda here, return false. Okay. We could do something like this. Lambda A, or A, okay? Say bool something is equal to a call of our lambda. So when we create a lambda that we're passing into our algorithm, we're just creating one of these lambda objects that overloads the parenthesis operator and calls the function. Alright, let's get rid of this. Now there's one more part of a lambda that's a little sneaky, and it's probably the hardest part to kind of understand, and that is the capture parameters, and they go in these square brackets. They're a little bit harder to understand, but what they tell the lambda is they tell the lambda how to pull in variables from the scope of that lambda. And the neat thing about a lambda is that it sees within that scope that it's declared. So if we want to capture our bad chars, let's say that we're going to do bad chars by reference. Wait, no. There. So we're capturing the reference of bad chars. What we can shorten this to is we're just going to do an ampersand in there, and that says any variable that the lambda can see that I use in the lambda function will be captured by reference. So now, if we do return bad chars, find first. Oh no, we don't even have to do find first. We just need to do find. Let's see if this character is in our bad characters. So we're going to say, we're going to remove it if it is not equal to standard string and pause. Alright. We're going to call find on our bad character string. Now that we have it by reference, we can just use that variable like it were in the scope of that function. So if I call find with a character, it'll look through the string and try to find that character. If it can't find the character, it will return end pause. So if we were to do something like this, bool should remove, and we grab, oops, let's grab this. Hopefully that's a little bit more clear. Okay, return should remove. Okay. So now we're checking to see if the character that we've been passed is in that bad character set. If it is, we're going to tell the algorithm to remove it. Alright, so we're almost done here. There are a couple of things that we need to do. First, what you need to know about standard remove if is that it does some crazy stuff. Well, it doesn't do exactly what you think it does. It's more of a stable partition. So let me explain. If we have our input file, here, let's go ahead and exit out and be input.txt. Alright, so let's look at this first example. We have the string, how are you? And we want to remove ABC. Alright, so standard remove if and standard remove will move all the characters that you don't want to the end of your container, and then it will return a pointer to the first character that should be erased. So if you look at, let's do the second example, hello world. So we need to remove E, so we'll put that in, L-O world. D goes then, so ED. Oh, there's no comma. It just, at the end our string is going to look like that. And it will return the position of that E character. So let's look at how we deal with that. Let's go back to this. So we actually need to keep track. Auto begin remove is equal to there. Alright. So now we can take our standard string that we have, our input text, and we can erase characters from it from begin remove to input text end. Alright. So now we're actually erasing the characters. Remove doesn't actually erase objects from your container. It just moves them to the end in a stable partition sort of way. At this point, and just for fun, let's just verify that we're getting the behavior. Raw line is that input, or raw input text, input text, and after remove if. And then after erase. Alright, let's go ahead and compile it. Now last time I forgot to add the flag WAll, and that turns on all warnings. Highly recommend, if you're going to do C++ development, turn on the warnings. The compiler is really smart and it knows when you're doing something that's dangerous. Every warning, if you just have the normal warnings on, are bad and should be fixed. When you get into like more pedantic, into like the W pedantic, those can be false positives and they're not quite as dangerous as the regular warnings. Alright, let's turn on our standard C++ 11 because we love it. Turn on the optimizations and alright, it compiled. And look, okay. Raw input text, how are you? After remove if, how you? That's interesting. And then after erase, how you? And hello world. Erase. So why are we getting, the result is correct except for we're removing spaces. So we need to remove spaces from our bad character. Oh, you know what? Okay, this makes sense. So what is, it's not actually moving the characters. Here, let's look at our input again. Oh, whoops, moving input text. Alright, so what it's doing is, we have this string, hello world. Okay, and if we want to remove a character, so we need to remove the E. So it's deleting this character and shifting everything down. But as you can see, it doesn't actually modify the character at the end, so this might be, you know, RD or something. You know, there's some goofy characters in there that are just kind of garbage, but it does point us to the correct point, so when we delete at the end, we're good. So yeah, so let's fix our issue with the space. Now we can either remove the space, or we can check for it in our lambda. So we can do if C equals space, return false. And we can make that a little bit better, but let's see what that does. Let's see if that actually works how we think it is. Let's run it. How are you? Hello world. Okay, that looks like it works. Oh, whoops, I didn't want to compile again. But rather than do it here, let's do another remove. But this time, and you gotta be careful because there's another standard remove which deletes a file, but that just takes in a single const char star. So let's just say bad chars begin, bad chars end, and this one we're not going to use the predicate version. So let's just remove all spaces. But this does the same thing. It returns the last location or the first location that you need to erase. So we're going to do bad chars erase from there, bad chars dot end. All right, let's see if that works how we're expecting it. That looks like it works. We're getting the same output. Awesome. Okay, so let's get rid of our superfluous debug output. And that looks good. Let's go ahead and submit it and see if it passes. Now, I've mentioned in the last video that the sandboxes for Code Eval are a little slow, but oh no, workspace, go with me. Upload. Moment of truth. We'll see if it actually compiles in time before it gets cut off, because like I mentioned, algorithm is a big character. Oh, look at that. Solved. Score 100. Time 3 milliseconds. So this worked great. So even though we had the algorithm, a lot of the other stuff we were doing wasn't very complicated, so it looks like it executed it quite nicely. We passed. Hurrah! The code, if you want to look at the code, I'm putting it on GitHub. It's under my repository. My username is Electron. You go ahead and find it. It's in the Code With Me repository. And I label these for each episode. You can see the corresponding code. If you have any questions, definitely feel free to ask below in the comments. Click on me to subscribe. And hopefully we'll see you next time. Thanks for joining me.